Hi everybody, this is Chen Chu. Today I'd like to demonstrate DynusT as in the GUI environment called DynusStudio. DynusT has been supported by Nexta as its GUI for years. DynusStudio is a new commercial software that has been developed for about 2 years by RST International. Recently, RST International released this DynusStudio version supports DynusT. DynusStudio offers much more expanded, optimized visualization and data analysis capability. So I'd like to take this opportunity to show the audience a little bit on how we can get out of DynusStudio in terms of DynusT and analysis results. There are a lot of features in DynusStudio, and including importing the data sets, network editings. I would skip most of them, but just focus more on the visualization and data analysis part of that. So right here in front of us is the SACOG network. Here I basically have all my information organized in terms of layers. Currently I have my different link types organized in terms of freeway, and I use them as navy blue color. All the arterial are in light gray. All the ramps are in terms of orange color for us to delineate the information later on. DynusStudio allows a user to run DynusT by clicking on this button. This button allows user to specify all the informations and then hit the run button. After run being executed, DynusT output files, particularly the trajectory file, will be automatically imported back to the DynusStudio environment. DynusStudio has its own internal databases. That's how you was able to optimize the display. There are a few options that user can choose to visualize the results, and all these capabilities can be accessed in this analysis tool button. I'll focus on a few that may be of interest to the audience. First of all, I would like to show the animated network performance plot. When I click on the network animated plot, what's been brought up to the window is a window has time bar, where here I'm able to show, in this particular example, the MOE is a cumulative volume over time. When I click on the pull-down menu, I'm able to see a number of different options. Cumulative volume for all traffics, for auto, or look at a flow rate, or look at a density, network level density for each link. Link speed % all means that this speed will be represented as a % loss compared to the free flow speed. All means just the average speed in the current speed for each link travel time, and queue length. So if I reset it and click on run button, before that I can also decide my bandwidth. It's going to show the flow volume in terms of bandwidth. I can choose to change different bandwidth. I can choose to run simulation at different frequencies. The default is 6 seconds. I can choose to run 5 intervals or 10 intervals. Let me choose default, or maybe choose 5. Refresh speed allows me to, the higher the speed is, the faster it's going to simulate forward. Okay, so let me move this control window to the side, and once I hit the play button, when you see the clock is advancing, I'm currently at 2 o'clock, 3 o'clock in the morning. This is a 24-hour simulation, so nothing happened just yet. But as soon as we get into the peak hours, now we start to see that freeways start to get pretty busy. This is a morning peak hour, and it's continuing to the midday, as well as, so now it's continuing advancing to the middays. The volume will continue to accumulate a long time. And later on, throughout this is at 2 o'clock, 3 o'clock, and then later on when we get into the PM peak, we see the band continue to increase further due to the PM volume. Right now at 6 o'clock, I'm getting to the PM peak hours. You can see that traffic continue to grow. And I'm currently at 8 o'clock. Let me pause that and zoom in to see a little more details. I can reset this. And we can replay the result again. We can have better ideas on the dynamic of the flow at different time of the day. Now I'm here in 6, getting to 7 o'clock, getting to the rush hours. So in this case, one can have a better idea on the dynamic temporal progression of the flow over time for the entire network. I'm getting into the PM peak right now. Okay, I can also now choose to show the density. This again is just for us to help us understand the level of congestion and the location of congestion over time. Let me change the bandwidth to a little bit shorter. I'll choose 10. Choose link density. Now when I start playing, and again in the early in the day, nothing really happened. You can probably zoom in a little bit more to see the traffic condition more close to a downtown area. Choose also to refresh a little bit faster. Again, here we're at about 2 o'clock, 3 o'clock in the morning, and that's just wait for the morning peak hours to come. Here we go, 6 o'clock, traffic started from here. And you can see the conditions start to build out along the freeways and getting close to the downtown area. The legend here is showing in terms of level of service. Currently, I'm showing density. So, the when you get into a warm color, orange, red, and black all stands for fairly severe congestion situation. Okay, so here is around midday. Traffic gets a little bit better. All right, getting to 2:30, almost 3 o'clock now. You can see the traffic start to build up again. And then currently, the origin of the congestion started close to here, downtown area. As we get into PM peak, traffic start to build up again. Okay, with 6:20 downtown area, outbound traffic still it's quite congested. Getting to 7:40, close to 8 o'clock. Now congestion start to disappear, and as we get into evening time, you can see that the congestion start to being dissipated. All right, so in the interest of time, I would not go through all of this, but you can have an idea that all this option allows us to check on link level performance for the entire network for the entire day. Before we move further, I'd like to show just get a sense about system departure time and arrival time profile. This diagram explains this is a departure time profile. Currently, you can see that the traffic goes up. This is in terms of 1 minute interval, and traffic start to increase during peak hour, dissipate, and gradually increase in the PM as well. The arrival profile, obviously, let me expand this. Again, mimic the departure or the shift stands for the travel time. Average trip times. You can see that the travel time, average trip time, could be look up to the right in morning. In terms of having a shock of a peak of the congestion is a little bit higher in the morning. Afternoon travel time, because traffic started gradually increase in the afternoon, so the congestion is not as bad as in the mid AM, which is about 44 minutes. PM there are some increase in terms of getting close to 30 minutes. Delay time, you can see that delay is right here. It's delay time as well as unfinished traffic. Usually it's pretty small as we have most of traffic accident network. So this shows a temporal pattern of traffic departure and arrival pattern. The select link analysis allows us to understand the traffic dynamic. Select link is pretty standard feature in most of traffic demand model. However, in here in DynusT, one can choose to query the select link analysis by different time of the day. For example, if I like to query all the traffic going through the freeway main lane, here, let me query this link. And then let me copy the link number to the clipboard and put it here, select link, paste this link. I would like to look at the travel time, all the volume from 6 to 9 a.m. and then going on this link, and I would like to show the bandwidth in terms of orange color, and I run a query. Now you can see after running the query, it shows all the traffic going through this link during that time interval in the morning hours. You can see this is the typical select link analysis. One unique feature of this capability is I can enter multiple links to actually to query a flow going through actually multiple links, essentially a specific route. So, for example, if I want to know all the traffic that sort of eventually lead to downtown area, you can click on this link again. This is somewhere with a link close to downtown. Right click and also click the link number, copy the link number to the clipboard, put a plus sign here, and the paste and the link. So I have two links, and the query would retrieve all the flow that going through both links. And now you can see that now the query results become more specific. Now it shows two links going through the volume going through both links, and that gives you more specific picture about flow on a specific route. I can click on show table. That will actually show me all the vehicles actually are being queried, and I can click on each row. You actually will show me the entire route of the vehicle. Now this vehicle looks like it's taking a pretty long trip, and its vehicle ID 65381. I can actually track this vehicle and later on, but here I'm just writing down the vehicle ID 65381. And so you can see that I can randomly click each individual record to be able to see the individual vehicles route. I can also query different vehicle type, driver classes, and I can also query a departure zone. So this query is fairly flexible by entire population, by links, also by departure time, you can query different departure time or by different zone. So if you want to query the PM peak, 15 hours, 17 hours, to 20, 17 to 20, when I run a query again, and that's a PM situation for the same link. So you can see that I'm querying just for the PM peak hour situation. All right. Then the next feature is the vehicle animated vehicle trajectory plot. This feature allows us to actually see the animation for the entire network. I can choose to animate for the entire 24 hours, but it's gonna take a long time to simulate. So here I'm going to just show from 6 to 10 o'clock in the morning, and I can put 653A1, the vehicle ID I just recorded. So when this vehicle shows up, you actually will be able to see the vehicle going through the network. That's on check no delay for now. So all the vehicle SOV will be shown as the red dots, green dots for HOV, and blue for truck. Stop and go vehicles, any of the three type of vehicle, when they experience congestions, in the stop and go situation, the color will automatically turn black. Check on vehicle ID. So in this case, this vehicle ID will be shown later on. When I click on play button, it first scans through all the vehicle trajectory files, and you can see that now vehicle actually is right here. It's actually start from here and it's actually moving now. The red dot may be turning black if this vehicle starts to experience congestion. So currently it's still moving along this freeway, and if you recall, the trajectory go all the way here through downtown area. I can speed up the animation. By default is 6 seconds. Again, it's probably take a long time to simulate, so I can turn into 1 second. This vehicle may be jumping because I'm refreshing every 1 minute. So in a minute, vehicle may be traveling a longer distance. If I choose to zoom in, you can see actually a lot more details. Again, the vehicle can be shown in terms of dots, but if we look even zoom in a little bit further, we even see the actual vehicle. So right now, let me turn off the vehicle ID so it's easier to see. Vehicle are now being shown as arrow. So you can really track. If I just switch to the default value, actually vehicle will move with. You can have a better tracking of vehicles movement on freeway, and the vehicles traveling in different lanes are actually following. There's different lanes on the freeway link. Now, if I decided to See a little bit closer into downtown area. I can also choose to turn on. So when we run the animation a little bit faster, we actually will see more of the stop and go vehicles. Right now it's 7:30, so we are going to see some black dots here. These are the stop and go vehicles. And if I let run every 10 minutes and I refresh a little bit faster, you can see the congestion start. There are some congestion here and here and here. This GUI also has the ability to actually highlight, so you can see this is inflow traffic getting to downtown area. Allows us to actually turn on the no delay. This is going to show us the intersection delay in terms of circles. So if I play again, you'll be able to see that those areas have started to show significant delays, more than 100-second delay. Will have a circle representing that kind of congested situation. Now pay attention to the PM peak then. Currently in the morning peak, you can see this inbound location are where we experience most of the delay. In the PM peak, you probably start to see the congestion direction change. Alright, so I'm here and only showing 6 to 10, so you will not advance because I'm already 6 to 10, and you can see that there are a few pockets of congestion. Now when I start to show 17 to 20, that's the PM peak hours. And let's go ahead and take a look at the congestion situation. You can see now the actually delay is, you can see delay is getting, it's still similar location, but it's actually in outbound. For the outbound traffic, you can see the outbound here is a little more delay. There are a few outbound locations, maybe on a ramp close to downtown area, they have a little bit more congestion. You can see here is the outbound locations. Now where this this result is realistic or not requires further calibration and validation based on traffic data. But this gives us a pretty good capability for us to either perform diagnostic of the system, codings, as well as interpretation of the results. And if we really want to see the entire network for the entire day, then we'll just put a 2359. And the GUI is going to rescan the entire network and all the vehicle trajectory, and then to replot this again. You can see that it's performing this analysis fairly quick. Okay, so we're getting to AM. Start to see a pocket of congestion for the inbound traffic in this area. Getting to 10 o'clock, congestion start to disappear. Here's not right now, it's midday. Traffic is still heavy, but not too bad. Getting to 3 o'clock, you start to see gradual build up of traffic again. Getting to the PM peak 4:30. Congestion in some of the ramps and as well outbound locations start to build up to the 5 o'clock. So traffic congestion direction is primarily for the outbound traffic direction. $7 o'clock. 7:30, 8. And condition gradually, gradually go away till the end of the day. All the DynusT output analysis are summarized in summary state convergence, or MUC. All these files are available for further reporting and analysis. With that, I conclude my short presentation on DynusT and DynusStudio modeling on the SACOG network.